Thank for your participation, cooperation. Greetings and welcome, ladies and gentlemen, page 2, 7, and 9. Here is a student's work of problem 23. Their first time using my writing tablet, so cut them some slack. And analyzing this problem here, y squared minus 12y plus 20. First of all, let's see. Does this match a pattern? Okay. Is this a perfect square? Yes. Is this a perfect square? No, it'd have to be like 25 or 16 or something like that. And then never mind that, but then the middle also would have had to equal negative 2ab. So this doesn't match a pattern. The second thing I'm going to check, well actually the first thing I would have checked is if there was a GCF, which there was not. And the leading term is 1 here, so that means I don't have to use AC method. So I'm just going to find the factors of C that add to B. So we've got 1 and 20. You don't actually need those parentheses there, but I see what you're doing. So 1 and 20, 2 and 10, technically 4 and 5 also would work. But the ones that add to be 12, ignoring the sign, are 2 and 10. So we have a y with a 2, a y with a 10. And to figure out the signs, we would have looked at this and said, they multiply to be positive. So the signs are the same, and then they add to be a negative. And two positives don't add to be a negative. So they must have both been negative. So well done to our student volunteer. You are now YouTube famous. Let's see, problem 24. Take a look at it. Look at it. 12ab cubed minus 8a squared b squared plus, I know I'm rewriting this, but that way people at home can see a little clearer. So the first thing I would do, looking at this, I think there's got to be something that can be GCF from this. Between 12, 8, and 10, what could I steal from those? 2. Between a squared, and a to the 5th, how many a's could I take? Just a to the 1st, right? Between b cubed, b squared, and b cubed, I could take at most a b squared. So, because that is the smallest degree present of all the b's. So I can take the smallest one that any given term has and take it from all of them. So 2ab squared, and I'm going to have outside a set of parentheses, and then I'm expecting a trinomial here because this was a trinomial, right? That makes sense. So 2 times what is 12 is 6. A is cool. 6b. Sorry if my 6's and b's look the same. That's life. 2 times what is negative 8? That's negative 4. A times a is a squared, and b squared I've already got. Good. 2 times what is 10 would be positive 5. A times what is a to the 5th? That would be a to the 4th. And b squared times what is b to the 3rd? That would be plain old b. And it looks like I can maybe rearrange where this parenthesis is here. And now the question is, am I done? Right? Can this interior be factored further? Because if it can, I should. But looking at this, no. I don't know how to factor that. That does not fit any of the forms that I am familiar with. So that means that is likely the answer. Maybe I would actually rearrange some of this. I might have put I might actually have rewritten it this way. So I would have written 5a to the 4th b minus 4a and then plus 6b. Because I prioritize alphabet and then exponent. So alphabet a to the 1st, and then here's an a to the 0. So that's maybe what I would have done, just to write it in more of a standard form or something like that. So there we go. Here's 29 coming at you. All right. Taking a look at this. First thing I should analyze, is it GCF? Can I GCF this? Is there anything that all of those terms have in common that I could steal from each of those? Now, technically, you could have actually AC method this first, but then your answer, you would have had to factor out a GCF. But it's actually better to do this 3 times n squared plus 7n minus 8. Because now this is actually easier to factor. I don't even have to AC method that. Does this match a pattern, actually? First term is a perfect square. Last term, no, not a perfect square. So I'm going to just regular old do this. I don't have to AC method because the leading coefficient's 1. So the factors of 8 are 1 and 8, 2 and 4. Writing this down, right? Different color writing utensil, right? Because gotta know how to do these. Oh. So here we got 3 times. I'll have an n with a. Oh, which of these do I want?
You want the 1 and the 8.
The 1 and the 8, because I wanted ones that subtract to be 7, right? So 1 and 8 sounds good to me. Good job. Good job. So n with a 1, n with an 8. And let's see, they multiply to be negative, so their signs are different. And they add to be positive. Tell me the logic.
1 is negative and the 8 is positive.
And why did you decide that?
Because the 8 would be more influential.
I love it. Yeah. Its results is positive, so the more influential number had to be positive. Perfect explanation. Let's see, last problem here. I've got 3a squared minus 27b squared. First thing we do, let's try to GCF. I think we can. Steal a 3 from all of those. A yoink, yoink. And I'll have a squared minus 9. Ah! That was a little lag there. Whew, man, that was scary. 9b squared. Now, question this inside. Can I factor this further?
Yeah.
In fact, is this a perfect square?
Yeah.
Is this a perfect square?
We.
Is there such a thing as a difference of squares pattern?
We.
Yeah. So, in fact, I think a equals a in this case. That's kind of weird. Even weirder, perhaps, is this. B would equal what? What?
3.
3b, because 3 squared is 9, b squared is b. So, the pattern I'm using, by the way, it's not a bad idea to write it down until you have it memorized. A squared minus b squared is equal to what? Yep, so memorize that one for sure. And in fact, if you were doing this problem and got stuck and you're like, I know A is this, I know B is this, I don't know what to do next, but I kind of think this is the pattern, write down the pattern or something. I might be able to give you partial credit or something, you know, who knows? Who knows? So I'm going to have A plus 3B and A minus 3B. 3B. So, there we go. Not bad. No es más mal. Eso más bien del mundo. No. Sí. All right. Adios. Adios, amigos de el internet. Bye-bye.